It took more than 12 years to launch all the pieces and put them together on orbit. Today, the work for the International Space Station crew is focused on building for the missions still to come.
What we're doing today, though, is we're learning how to build those systems to last longer. We're learning how to keep the people healthy so that we can last longer, be effective, and get the job done.
The job is building the capability to send people beyond low Earth orbit while improving life on Earth in the process. Longer missions, farther away from Earth than ever before, will raise new challenges, and mission planners need to know how the hardware and the humans can handle those challenges. For example, a person's bone density decreases very rapidly while in microgravity, 10 times the rate of decrease in a person with osteoporosis, and that means greater risk that an astronaut could suffer a broken bone.
So in order to prevent that, astronauts exercise every day 1 to 2 hours. And in addition to that, we as guinea pigs take pills, which is used for treatment to cure the osteoporosis on the ground for preventive purposes.
Bone loss is one negative effect of being in space. Crew members are subjects for research designed to discover more precisely and in what ways the space environment impacts a human body.
We collect samples, urine, blood, things like that, and those get returned to laboratories on the ground, and they help the scientists there with much more sophisticated laboratory resources to be able to figure out how to further mitigate those kinds of effects. So, in short, NASA's primary goal for the human research on space station is basically to make it safer for us to go further.
These same people who are subjects for some science research are also the hands-on helpers for other experiments, working with researchers on Earth to take advantage of the facilities in the station's several laboratory modules and of being in orbit more than 200 miles high.
It can be medical biological experiments, experiments that study the production of different materials in space, geophysical experiments, experiments on the study of Earth.
For example, in the laboratory, crew members monitor plant growth facilities where seeds are grown inside canisters which are rotated at different rates to simulate different levels of gravity. The seeds will be analyzed and compared later on Earth.
All these seeds started at the same time. You know, what do they look like in 0 G, and what is 1/4 or 1/10 of a G? What does that do to the plant? 0 G plants are kind of weak, actually, because they don't know where to grow. They just grow toward the light, and that's another variable in that experiment.
In another experiment, crew members focus a combination camera and spectrum analyzer on the sunlight reflected off of the Earth to refine the procedure for measuring levels of carbon dioxide and methane in Earth's atmosphere.
And having this data, scientists will be able to understand better the processes in low troposphere, which is very important to understanding the changes in the climate of the Earth.
The International Space Station is the place where the crew members work, but it's their home too, and they spend part of each day tending to its needs. Crew members are trained on all the systems, but no one can know what might break down or when.
That is why we have scheduled maintenance, of course, because everything, unfortunately, that mankind build get the expiration date. We need to perform the replacement.
Burbank takes over as Expedition 30 commander when Fossum, Volkov, and Furukawa come home in November, and the crew grows in December with the Soyuz arrival of former station flight engineers Oleg Kononenko and Don Pettit and European Space Agency astronaut Andrei Kuipers. Expedition 30 is expected to greet the arrival of Dragon, the world's first commercial supply ship.
With the retiring of the space shuttle, we've now lost the ability for to carry very big, loads of cargo to the station and to return cargo from the station. So what we've done is we phased into basically a new chapter here where NASA is going to solicit and contract with commercial providers to do exactly that.
Dragon is a spaceship developed to carry cargo in the nearest future accrue to the station, and it can deliver up to 6 tons of supplies to the station. And what is important, it can return to Earth up to 3 tons of supplies,
which none of the station's other uncrewed supply ships can do. The Dragon spacecraft is being developed by Space Exploration Technologies Corporation under NASA's Commercial Orbital Transportation Services program. Similar to the Japanese HTV cargo ship, Dragon will rendezvous at the station, then hold position so the crew can reach out with Canadarm2 to grab it and plug it in to the Harmony module. Another commercial craft, named Cygnus, under development by Orbital Sciences Corporation, is on the manifest for its first demonstration flight a couple of months behind Dragon. Expedition 30 has a Russian segment spacewalk on the plan in early 2012. Shkaplerov and Kononenko will install new debris shields on parts of the Zvezda module and a materials exposure experiment on the Poisk module, and Shkaplerov will collect bacteriological samples from the station's exterior hull.
I will take some kind of a swab from there and will send it to the ground to the scientists so that they could study them and determine whether there is a great corrosion going on, or to determine for how long the station can continue to be flying.
The mission of the International Space Station is planned to continue until at least 2020, years when the station's partner nations will add to the wealth of knowledge about human spaceflight and use that knowledge to help the people of Earth while getting set to launch the missions of the future.
We have a toehold or a foothold in space right now, but it's not deep space. It's still largely shielded by Earth's magnetic field, but we still have great things we can do in low Earth orbit to figure out how to keep humans and hardware functioning well so that we can do those next missions.